Our universe was born some 15 billion years ago in a great eruption we call the Big Bang. Space dilated and billions of galaxies formed in the cosmos. Each galaxy contained billions of stars. Black holes, too, made their appearance. In one of the vast spirals of our own galaxy, the Milky Way, the Sun and the Earth, 5 billion years ago, first took the cosmic stage. This film tells the story of life's beginnings and its evolution. We will see, as the tale unfolds, forms of life much like the earliest to exist on Earth, most of which have been long extinct. The Sun, with its immense corona, was the energy source that fueled our corner of the universe when the Earth was but a gigantic furnace. The first rocks began to crystallize. Slowly, the Earth cooled. This Earth was a desert. No animals, no plants, no life. And no blue skies, for the atmosphere contained no oxygen. There was no water on the Earth's surface. Cast forth by volcanic eruptions, it collected, all of it, in the skies above. The first rain. Boiling hot, it poured down for millions of years. Because of the Earth's mass and its position relative to the Sun, its atmosphere did not drift off into the cosmic void. Water was held to the Earth's surface as a liquid, as a solid, and as a gas. The oceans formed. It was in water that life began almost 4 billion years ago. But how? It could have been in the dark depths where sulfurous springs bubbled up, heated by the Earth's magma. Or it could have been in pools of organic matter, where space dust had come to rest. Or it may be that minerals provided a scaffolding around which living matter organized itself. What was this life? At first, just a group of molecules enclosed in a membrane, drawing energy from beyond itself and reproducing, whether by duplication or in forms that alter and diversify. All species are thought to descend from a common forerunner that appeared almost 4 billion years ago. We call it the Luca, the last universal common ancestor. The first living beings were bacteria. They drew their energy from a chemical reaction called chemosynthesis. Some unicellular creatures, cyanobacteria, used the sun's luminous energy to produce oxygen. This was the first photosynthesis, a process later to be adopted by the chlorophyll in plants. Oxygen was still a rare gas and a danger to living things. Expelled into the air, slowly it altered the atmosphere's character and its properties. About 1.5 billion years ago, the cell developed a nucleus, enabling it to protect its genes with a surrounding membrane. life will have remained microscopic and unicellular for almost 3 billion years. Every drop of water contained a world. 700 million years after the nucleus emerged, the first multicellular organisms began to appear. In time, life's basic behavior patterns began to assert themselves: movement and feeding. Now we had a food chain. A balance evolved between plant and animal life, with the latter most often consuming the former. Cell division took care of reproduction, the simple principle of one cell splitting to become two. Asexual replication, life on the assembly line, efficient, but rather lacking in innovation. Some unicellular creatures began to join forces, enhancing the size and complexity of living beings. The sponge, long thought to be a plant, was one of the first animals to live in a colony. Life had been exclusively unicellular for almost 3 billion years. But then, for 670 million years, invertebrate multicellular marine animals were to have their day. Tiny animals, together with microalgae, formed enormous coral reefs. The coral was constructed for the most part by colonies of polyps, minute tubular creatures topped with tentacles that reeled in microscopic plankton. These tiny, strangely shaped invertebrates provided most of the nourishment for the coral reef. Eventually, these multicellular animals sprouted organs with specific attributes. The sea urchin's ambulacra moved it along, while its spines protected it. The sea urchin's mouth and teeth were set on an axis. This axial symmetry showed up also in starfish, brittle stars, and feather stars. This spiral tube worm deploys its branchiae. Oxygen given off by algae monopolized more and more of the atmosphere. The sky took on the hue we know today. While there was still no life on dry land, it was burgeoning beneath the sea. A little over 1 billion years ago, life on Earth made a quantum leap. Life forms began to reproduce sexually. Starfish consummated countless fertilizations without ever touching. Sea urchins, male and female, released their seed into the water at the same time. Clouds of sperm intermingled with clouds of ovules. What seems wasteful to us helped compensate for the dangers future larvae would face. A sperm cell could now merge with an ovule and produce a fertilized egg whose genes came half from one parent and half from the other. Fertilization brought with it diversity, each organism unique. And with new genetic horizons opening up, evolution moved into high gear. Dividing, the egg transformed itself into a larva. These larvae, mixed with plankton, disseminated the species. The larva of the sea urchin, the larva of the scallop, the larva of the starfish, all swept away by the prevailing currents to mature and grow to adulthood far from their origins. To give fertilization more of an edge, some species began to meet in the flesh. Sea slugs, being both male and female, formed a mating chain. Sexual reproduction was a resounding success. It was 600 million years ago, and life in its infinite variety had come into its own. Diversity had won the day. One of the great success stories of evolution was the Copepoda, which were more numerous than any other animal group on the planet. These tiny crustaceans were an important link in the food chain. Carried along by the ocean currents, they were a major constituent of plankton. Many plankton were translucent and gelatinous. Like some of these creatures, the Venus's girdle was quite large. "10,000 feet down, in the vicinity of hot springs, and under extreme conditions, life continued to flourish. Minerals in the water made possible the development of shells and bony plates. The shell of the horseshoe crab has warded off its enemies for millions of centuries. mollusks such as the nautilus have survived virtually unchanged for 500 million years. Now came the eye, a huge leap forward in evolutionary terms. The first photosensitive cells began to produce an actual image. The eye of the cuttlefish was already highly developed. Capturing prey was no longer a hit-and-miss affair. The eye allowed for a sure and steady aim. The more efficient the eye became, the more invisible you had to be. The octopus learned to camouflage itself by mimicking its surroundings. This 6-foot-long sea cucumber assumed the color of the seabed. While another species of sea cucumber used gluey filaments to defend itself. Weapons became more sophisticated. Stingers, darts, and venom-tipped tentacles like those of this formidable sea anemone. Evolution did not always proceed smoothly. There were several massive extinctions, due most often to climate change. 530 million years ago, 80% of the existing species died off. Much of this fauna in fossil form has been found at the Burgess Shale in Canada. Fortunately, Pikaia, the forerunner of all vertebrates, is among the 20% that survived. The lancet, which resembles the Pikaia, is thought to be the evolutionary precursor of the fish. Despite its plant-like appearance, the Ascidian was an animal, a close relative to the vertebrates. Among the plankton there were many animals, such as the salpa and the appendicularia, both ancestors of the vertebrates. About 400 million years ago, the first shell-free animals began to appear. They had solid flesh and an internal skeleton. First came the cartilaginous fish like the ray and the shark. Then, fish with bones. All these extravagantly formed animals testify to the richness of the evolutionary process. The seahorse. The crocodile fish. The lungfish was one of the first creatures to emerge from the sea and to breathe in the air, now abundant in oxygen. It joined the plants and insects that had preceded it, and inaugurated a whole new saga, as the vertebrates began their conquest of the continents. One chapter was over, another was ready to begin. Life began in water 4 billion years ago. It has existed on dry land for only 400 million years.